Something strange is happening inside modern artificial intelligence. Researchers are building systems that can perform incredible tasks. They can write essays, answer complex questions, generate images, even help design new medicines. But there is one problem. In many cases, even the engineers who built these systems cannot fully explain how they work. This mystery has led many researchers to describe advanced AI systems as black boxes. You can see what goes into the system, and you can see the results that come out. But the decision-making process happening inside the neural network can be extremely difficult to interpret. Modern AI models are built using artificial neural networks, systems loosely inspired by the structure of the human brain. These networks are made up of millions or even billions of parameters. Each parameter adjusts slightly during training as the system learns patterns from enormous data sets. Over time, the network develops internal representations that allow it to perform tasks like recognizing images, translating languages, or generating text. But the complexity of these networks creates a major challenge. As the models become larger and more powerful, understanding exactly why they produce certain outputs becomes increasingly difficult. Researchers at companies like OpenAI, DeepMind, and Anthropic have openly discussed this issue. Even when an AI system performs a task successfully, the reasoning behind its decision may not be fully transparent. This problem is known as AI interpretability. One researcher who has worked extensively on this topic is Chris Olah, a former research scientist at OpenAI. Olah and his colleagues have spent years studying ways to visualize what neural networks are learning internally. In some experiments, researchers can identify patterns within networks that correspond to recognizable features. For example, certain neurons may activate when the system detects edges in an image or specific shapes. But as networks grow larger, the patterns inside them become increasingly complex. Instead of simple features, the system begins forming layers of abstract concepts. Understanding these layers becomes far more difficult. Another challenge is that neural networks do not follow step-by-step logical reasoning the way traditional software does. Instead, they rely on massive statistical relationships learned during training. This means the path from input to output can involve millions of tiny interactions between neurons. Even though researchers designed the system, the internal logic that emerges during training can be difficult to trace. Because of this, scientists are now studying ways to make AI systems more interpretable. Understanding how AI makes decisions is critical for safety, reliability, and trust. If AI systems are used in medicine, law, or engineering, researchers need to understand why they produce certain conclusions. Without transparency, it becomes harder to identify errors or biases inside the system. Despite these challenges, the field of AI interpretability is advancing rapidly. Researchers are developing new tools to peer inside neural networks and better understand how these systems process information. But for now, one fact remains clear. Some of the most powerful AI systems ever created are still only partially understood. They can solve complex problems. They can generate human-like language. But the full story of how these digital minds operate is still unfolding. Welcome to AI Frontier, where we explore the discoveries shaping the future of intelligence.